Okay, I want to think about the problem 1 and 9/10 times 4/10. And one of the things I want to remind you, when we multiply, we're thinking groups of, so 3 groups of 5 is what that means. And so this is 1 and 9/10 groups of 4/10, or I can think commutative property, and I can think of 4/10 times 1 and 9/10. So I'm only getting 4/10 group of this 1.9, and I like to think of it as money because as soon as I put that 0 there, I think of $1.90. So I'm only getting 4/10 of the $1.90. Basically, that means if I could cut the $1.90 into 10 pieces, I'm only going to get 4 of them. So my answer has to get smaller. It's not going to get larger. So I'm going to cut this into 4 pieces, and I'm also going to go back and add my labels. And so one of the things I'm going to do is this whole section is 1.9, but this section right here is the whole, it's the 1, and this section right here is the 0.9. And then I'm looking at this section, and it's 0.4. And so if I think about that, and I think about it being multiplied, I'm going to go ahead and shade in. Everything else down here, we're not using. We don't get to have this because we're only getting 4/10 of it. So I'm going to shade it in so I can kind of see on my model. And one of the things I told a class the other day is I like to think of it as money. So this is really 4/10, or I like to think of kind of as 40 cents. And one of the things I did when I showed a class the other day is I drew my tenths separate like this, and it was a mistake because then when I cut across, I started counting these spaces in between as being part of the problem. So watch out for that. See how I've drawn my tenths? They're all together. And so watch out how you draw it, because that was my mistake, and I make mistakes too. And so I'm going to go ahead and color the next section, and this next section is hundredths, and there's 4, and here's 4 more, so now I have 8 hundredths. But if I go ahead and put 10 together, it makes a tenth, or like I said, I like to think of it as money, so I'm thinking kind of as 10 cents. And then I'm going to color in the next section. I'm going to color in 10 of those. And I can think of that as another tenth, or, because money's so easy for me to count, I'm going to think of it as 10 cents. So I have another 10 cents. And then I'm going to color in the next section. And there's 8 and 2 more. That makes 10. And I'm going to label it. And again, still thinking money because it's so easy for me to count that in my head. And then I look at this last little piece, and I don't have enough to make a tenth. Oops, sorry, wrong color. I have 2, 4, 6. I only have 6, but remember, I'm thinking money, so I'm going to think of it as 6 cents. So if you look at this, because money is so much easier for me to count, I went ahead and added those zeros. So I have 40 cents and 10, 10, 10. Well, 40 and 30 cents makes 70 cents. And then I have 6 pennies over here. So 70 cents and 6 pennies, my answer is 76. Hundredths are 76 cents. Because like I said, when I think decimals and I think money, it makes it so easy. And then I want us just to double check with the standard algorithm. Our standard algorithm would be 1.9 times 0.4. And make my decimal point a little better. And if we look at that and we think about it, I like to think about 9 times 4 is really just 36. So I'd put my 6 here, but I can't put my 36 because that's the ones place, so I have to regroup. But I'll be adding this. And I'm going to think about 4 times 1 is 4, but I need to add 3 more, so I would definitely get a 7. But the thing about it is, There's 1 behind the decimal here and 1 number behind the decimal here. So I need to have 2 numbers behind my decimal point. So I have to put my decimal point and make sure I have 2 numbers behind it, and I do. So my correct answer, same answer. Now, I want you to try, look at my model. Remember, I didn't label them with just tenths. I went ahead and labeled them as money, thinking about 40 cents, 10 cents, because that makes it so much easier for my brain to accept and to add it in my head. Were to do these equations, what answer would you get, and can you draw them? Now remember, if you don't like the way the number is, you can always use commutative property, and you could rewrite it if it made it easier to solve or to draw a model. So remember, you don't have to necessarily do it in the order that it's sitting in front of you, because this is multiplication. On multiplication and addition, we do get to have that commutative property where we can flip-flop and move the numbers around so that it makes it easier, because it's a lot easier for me to draw 2 and 3/10 as my starting number than it is maybe to draw 8/10. So try these, see if you can draw them with a model, see if it makes it easy, and then try it with a standard algorithm, or you can try it with a standard algorithm and check it with the model. But we do want to see both the algorithm and the model, because we are required to be able to recognize this equation as a model. So good luck, and I can't wait to see how you do.